Next problem, ninth one. As I said, this is JEE Main 2017 problem again. Okay. F is a polynomial function such that f of 3x is equals to f dash of x into f double dash of x. So from there we need to check these options. Okay, option 1, option 2, option 3, option 4. We need to choose the correct option. These are the options given in the problem. Okay, f is a polynomial function. So since f is a polynomial function, you just let degree of f of x is equals to n. Since it is a polynomial, it must have certain degree. Let the degree of f of x as n. See, since degree of f of x is n, then degree of f of 3x is again n. Since degree of f of x is n, degree of f of 3x is n. And since degree of f of x is n, its derivative has degree just 1 less than this n. Okay, so degree of f of 3x is n, degree of f dash of x is n minus 1, and degree of f double dash of x is n minus 2. Okay, see, if you differentiate a polynomial, then the degree of that derivative of given polynomial is 1 less than the degree of the original polynomial. Usually it happens, right? Okay. Now just think about this given relation. See, f of 3x is a polynomial which is the product of these two polynomials. So what is the degree of this right side? Product of these two. That means, see, when you multiply these two, the degrees we need to add, right? So as given, okay, or otherwise that implies degree of left side polynomial is equals to the sum of the degrees of these two, n minus 1 plus n minus 2. If you simplify this, n is equals to 2n minus 3. From there, n is equals to 3, and we need to conclude degree of f of x is 3 finally. Okay, therefore degree of f of x is 3. Since the degree of f of x is 3, it's a cubic polynomial. So let f of x is equals to, since it is cubic, ax cube plus bx square plus cx plus d is the f of x. And now treating this ax cube plus bx square plus cx plus d, a general cubic polynomial, as the f of x, we need to check this condition again to find the values of a, b, c, d. Okay, first of all, copy this till now. I will erase it and then I will continue. Okay, first of all, we are concluding the degree of f of x. From there, we are taking f of x in general form. So now we need to find the coefficients a, b, c, d to conclude the problem. Okay, copy this till now. Think about it. Okay, since we are taking f of x as this, now as given, f of 3x is equals to f dash of x into f double dash of x, right? F of 3x means replacing x with 3x. So what we have? F of 3x. So replacing x with 3x, it becomes 27ax cube. If you replace x with 3x, it becomes 27x cube, right? Plus x square means 3x square, 9b x square. Plus replacing x with 3x, it becomes 3cx plus d. This is f of 3x. This is equals to product of f dash and f double dash. What is the derivative of this f dash? For ax cube it is 3ax square, and for bx square it is 2bx, plus for cx the derivative is c. So this is f dash of x into f double dash. That means derivative for this f dash. For 3ax square it is 6ax, and for 2bx the derivative is 2b. There, product of these two is equals to the left side f of 3x. You just compare the corresponding coefficients, you will get a, b, c, d. First of all, think about x cube term. Left side coefficient of x cube is 27a, whereas coming to the right side, 3ax square into 6ax. If you multiply these two, you will get x cube term, whose coefficient is 6 3s is 18a square. So okay, comparing coefficient of x cube. After that you just compare the coefficient of x square. What is the coefficient of x square? Here we have 9b x square. The coefficient of x square from the left side is 9b, whereas coming to the right side, 3a x square into 2b. And it is 6ab plus 2bx and 6ax. This product also generates x square, whose coefficient is 12ab. Okay. So, 9b is equals to 6ab plus 12ab. Okay. From there also we have a chance to calculate a again. If you remove this b from the second relation, 9 is equals to 18a, right? So a is equals to 9 by 18. That means do we commit any mistake here? 3a into 2b. Okay. 6ab. 12ab x square. From the first relation, what is a? This is the first relation, this is the second relation. So just cancel out a, and a is equals to 27 by 18, 9 threes and 9 twos. This is 3 by 2, right? Then we have 3 by 2. See, by comparing coefficient of x cube, we get that a is equals to 3 by 2. See, the given relation is acceptable for all the comparisons, right? By comparing x cube coefficient, a value is 3 by 2. By comparing x square coefficient, we have this particular part. Okay. So, you need to use that a here. Okay. Don't cancel out this b. If b is non-zero, then you have a chance to cancel out. From there, you will get a as 1 by 2. But that 1 by 2 is not acceptable in this comparison, right? Comparing coefficient of x cube. So, see, these two are equal only if b is equals to 0. Okay. If b is non-zero, then we have a chance to cancel out. If you cancel out, it contradicts this a value. So, cancelling b is not allowed here. So, b is 0. A is 3 by 2, b is 0. Just by comparing coefficient of x cube and then coefficient of x square. Similarly, if you compare coefficient of x and constants, you will get c 0 and d also 0. At the end, a is 3 by 2, b is 0, c is 0 and d is 0. So finally we conclude, hence f of x is equals to a in the sense 3 by 2 x cube and all the remaining 3 terms are zeros. So f of x is just 3 by 2 x cube. If you have f of x as 3 by 2 x cube, then what you say? F dash of x is equals to 3x square, that means 9 by 2 x square. F dash of x is 9 by 2 x square. From there, f double dash of x is 9x, 2x, and then 2 gets cancelled. So f of x we have, f dash of x we have, f double dash of x also. Now replace x with 2 everywhere. At x is equals to 2, f of 2 is simply 2 cube, which is 8. So 2 4s and 4 3s 12. F of 2 is 12. Here what you say? F dash of 2. 2 square, 4, 2 2s, and this is 18. And then f double dash of 2 is directly 18. Okay. So we need to check. F dash of 2 and f double dash of 2 both are equal. And so this option is correct. Okay. Just think about it.